Hello. Hello. Good morning to everybody. Hello. Please stay on the line. Okay, welcome to all. Now this is the fourth semester of mathematics. Now this is the algebra paper. Now algebra, it is commencing with the sets concept, and this is there are 4 blocks here, especially first block is groups 1. Now in this block especially we will discuss some more concepts of now we are beginning with the sets, relations, and functions, and the second one is the groups, and third unit is the subgroups and cyclic groups. Now in the same manner there are another 3 blocks are there. Groups 2 is there, and third is the rings and fields, and especially fourth one is the isomorphism of rings. Now there are 4 blocks here, especially first block it is also concerning with the definition of it is commencing from group theory definition. First of all, what is the group? Now first of all, what is the algebra? Here the algebraic concept must be surrounding the concept from set theory, relations, and functions. We will discuss some other concepts of what is the sets. Already we have learned in the set concept is there. In the previous classes, just we will see here sets, relations, and functions. This is the unit 1. Okay, students. Now, especially this part is also commencing with the definition of a group. First of all, what is the group? Group is also well defined of the definition. Now it is commencing with the set theory concept. What is the set? Now that is the collection of the data or collection of the objects. Now here the objects are called elements. Okay. Now those elements are denoted by the numerical elements given in the bracket system. Now capital A equal to, suppose this is the collection of objects is called a set. Now those objects are denoted by, just you have to say here, in the alphabetical elements or some numerical elements giving the objects of this part. Especially here, capital A equal to set of 1, 2, 3, 4, 5. These are all 5 elements given in the set is there. In the same manner, capital A equal to here, ABA, one of the element is there. Okay, listen carefully. Here, capital AB any one of the set, here A being any one of the integer. That integer lies between, now it is greater than 0 and but it is less than 6. This set of the elements represented as in the roster form, capital A equal to set of. Here these elements are denoted by small a1, a2, a3, a4, a5. Or in the particularly numerical concept is 1, 2, 3, 4, 5. This is the collection of the objects. These objects are called elements. Okay. Now here the capital A equal to, now these set of the elements must be represented as in the roster form, small a being one of the integer. That integer represented as, here A lies between 0 and 6. Here A is especially greater than 0 and but it is less than 6 is there. But here 7 is not in A. Therefore 7 it is not less than 6 is here. Okay. Now that is the representation of the given the set is denoted by capitals, purples. Alphabetical letters are also well defined here. The alphabetical letters, capital A, capital B, capital C. These are all identification purpose for the notation as the set theory concept. Here the some sets are also denoted here. Okay, 5, 6, 7, 8, and these are all elements. But here 2, 3, 4 is also particularly given the set is there, and 1, 9 is also including given in the set. But here set of 2, 3, 4. This is the particularly one of the element given in the set. Okay, now already we have practiced in the previous classes what is the set and what is the order of a set. That is also cardinality of a set. Now suppose here the null set is defined as, because given the set there are no elements. The set not containing any element, that is called a null set is there. Now in the same manner, null set is also empty set here, that is denoted by pi. Okay. Now this is the basic representation of a set is there. Okay. Particularly now every set must be defined. One of the subset is there. What is the subset of the set? Now subset is also corresponding the set and some elements are particularly defined given in the set, that is called a subset is there. Suppose here A and B two sets. Okay, sir. Now these two sets such that every element of A, given the A, every element of A is an element of capital B. Now that is also said to be A is a subset of B is there. Now that is the notion of A is contained or equal to B is there. Suppose A equal to B is there. What is the equivalence of the sets? The given two sets, it is consisting same number of elements, same elements given the set. Number of elements is same. Now that is the equal sets are there. Here that is also represented as A contained or equal to B or B contained or equal to A. Okay. Now that is denoted by A equals to B is there. First of all, we must preliminary part given the algebraic concept. First of all, so what is the set concept? According to the set, how to construct the function, and according to the set and the function, we must define some relations according to the functional sets. Okay. Now, here what is the proper set? Proper subset is denoted by A contained or equal to B, and here A not equal to B. Here A is said to be a proper subset of B. Proper subset of is denoted by, because here A not equal to B when A is contained or equal to B. Now here the A is said to be a proper subset is denoted by A contains B. Now it read as A contains B or A is subset of B is there. But here A is not a subset of B, represented as A is not in B. Okay, sir. A is not consisting of B. It read as A does not belongs to B. In sometimes A does not belongs to B, or A is not consisting of B. A is not consisting of B. Okay. Now every empty set is a subset of every set is there. Okay, sir. Now here are some examples represented as the given there are two sets is there. A equals to 2, 4, 6. Now this set A represented as one of the set. That set is consisting of B is there. Now B set is just you have to see here 2, 4, 6, 7, 8 is there. The same elements represented in B is there. So that is the A is a proper subset of B is here. Okay, sir. In the same manner, what is the just you have to see here? What is the capital N? It read as capital N means the set of all natural numbers. Natural number set is denoted by set of 1, 2, 3, 4 and so on is there. Okay, sir. Now, okay, sir. Just see here, the set of all natural numbers is denoted by, it is commencing with the one is the least natural number is there. Here the set of 1, 2, 3, 4 and so on. And here the script Z is there. What is the Z? The set of all integers. First of all, so what we must know some representations. What is the N? What is the Z? What is the Q? What is the capital R? What is the capital C? Now, these representations are already we have to discuss in the previous classes are also there. Because in the lower classes, already what is the capital N? That is the set of all natural numbers. Natural numbers are also well defined in the lower classes. And it is also suppose just we have to discuss some in the same time. What is the N? The set of natural numbers is denoted by set of 1, 2, 3, 4 and so on. That set represented as the capital N is there. Here the capital Z is the set of all integers. Integers of the set -2. So -3, -2, -1, 0, 1, 2 and so on. Now in this pattern, the sum of the negative integers and including with the positive integers represented as the integers of a set. Integers of the set particularly denoted as capital I or Z is there. Okay, sir. Now these are all negative integers means -3, -2, -1. Positive integers that is also represented as Z minus or I minus. Here Z plus is positive integers is 1, 2 and so on. all positive integers it is comparing it with the natural number system. Natural number set is there. Okay. Here the capital Q is the set of all rational numbers. Rational numbers, what is the rational number of the form? Now here the rational number of the form is P by Q. Here P and Q being the integers, particularly here in the denominator, that integer must be not equal to 0. Here the rational numbers of the set of the form is set of P by Q such that P and Q both are integers and here Q is not equal to 0. What is the set of all rational real numbers? Real numbers is denoted by capital R, and the same manner complex numbers is also set is denoted by capital C. What about the relation natural numbers, integers, rational numbers, real numbers and complex numbers? Now these are all proper subsets. When the natural numbers must contain integers, integers contains rational numbers contains real numbers contains complex numbers. Now that is the relation. Enter the concept is natural and integers, rational numbers, real numbers and complex numbers. N contains Z, Z contains Q, Q contains R contains capital C is there. Okay, sir. Now, particularly in the set theory concept is there. Now, this is the basic concept. Now, especially in this session, only one short answer is given in the final examination. So that's why now this is the learned concept is there. First of all, preliminary concept of algebra is there. Okay. Here, capital A be the finite set. What is the finite set? Suppose given the set is must be a finite, it consisting of the elements when it is finite. Suppose capital A is there. That set is given the set is set of 1, 2, 3, 4, 5. Those elements are finite. So that is the finite set. When the set is consisting of the elements is finite, that is called a finite set. Otherwise, it is an infinite set. Now the set of all subsets of A. Here, suppose first of all, observe the given the set is there. Capital A being one of the set. That set must be a finite set is there, and that finite subset must be represented as some of the subsets. Those subsets is called power sets of A and is denoted by those according to the finite set. When we must write down some subsets of A, that is called the power set, that is represented as P of A. Okay, sir, that is the power set representation. Suppose just you have to listen here. See this one of the example. Capital A equal to 1, 2, 3, and power set is empty set. First of all, because there is no elements, power set is also commencing it with the empty set is there, and only one element, only one element given the set, that is also one of the subset. 2 be the only one element given in the subset. 3 be the only one element, and according to the finite set, we must write the some subsets given in the set, proper subset. So empty set 1, 2, only singleton element 3, and set of 1, 2, and set of 1, 3, and set of 2, 3. And set of 1, 2, 3, and finally given the finite set is represented given in the proper subsets capital A. Now these are all write the concept of power set representation. Okay, sir. Now this is also one of the good example. Now that is also not necessary here. What is the union of the set? Okay, union of the set represented as A union B. Now that is the combined, all the elements must be represented in the both the subsets. Suppose A and B be any two sets. The union of the sets, the set to whose elements belong to either A or B. This is the union. Union means that is the overall the elements.
Second form explain
sets. Okay. Now we read as A or B or A union B. Now that is the roster form is suppose X being any one of the element given in the set, that represented as X belongs X being A or X being B is there. Now it read as X is in A or X being A or X is consisting of A, whatever it is. Okay. Tell me, madam, Ramya madam, tell me. Hello. Tell me, madam. Hello, Ramya ji.
Sir, please explain, check your problems.
Please, hello?
Hello?
Oh, tell me,
second problem, explain, Jayan, sir.
Please stay on the line. Please stay on the line. Please stay on the line. Hello? 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 Hello, Ramya. Can you hear me? Hello? Hello?
Hello,
Tell
sir.
me, Ramya, madam.
Sir, check your progress and problems, sir. I've explained you, sir. Please explain the
Okay.
problem.
Okay, please stay on the line. Now, this is the primary concept of algebra. Okay, now enter this concept. Already we have practiced in the lower classes. Okay,
Yes, yes.
after 5 minutes, we will define the group definition. That is the main part of algebra. Okay.
Okay, sir.
Okay. Please note down my number, my dear students. Please note down my number. Any doubts? If you have any doubts, please contact this number through WhatsApp. Okay.
Okay, sir.
Please note down 99 89 47 68 33. Okay. Now, this is my number. Please connect the newly create the one of the member create the algebra group. Okay. Now, all the students must be formed. One of the group is there. We will discuss much more subjects through WhatsApp and some other doubts are there. Okay. 9989 476833. After the class, after especially this session, we will discuss much more doubts through WhatsApp number. Okay, madam?
Okay, sir.
Okay. Okay. Now, okay. What is the A union B? Means here, especially the union of A and B is defined as the whose elements belongs to either A or B. Now, here A union B represented as now combining both set of the elements, that is the represented as A union B means A or B. It read as A or B. That is the roster form. Here, suppose X being one of the element, that element is in A or that element is also in the B is there. Now, here especially, what is the intersection of this part? That is the common elements of A and B, that is called A intersection B, whose elements belongs to both A and B, and we write this as A intersection B means common elements in both sets. Suppose capital A equal to 1, 2, 3, 4, B equal to 2, 4 is there. What is the A intersection B? Here, anybody is there? That is 2 and 4. 2 and 4 is the A intersection B is there. That is the roster form. Here, X being any one of the element, that element, please stay on the line. Okay. Now, that is A intersection B means that is the common elements given on both sides. That is A intersection B represented as the roster form is here X being one of the element, here X belongs to A, intersection represented as the in the lattice concept, that is AND. Now this is the symbol of intersection means now that is AND part. X belongs to A and X belongs to B is there. Suppose both sets are disjoint. What is the meaning of disjoint? These definitions must involved in the further concept, especially group theory. That is the much more part from the commencing of group theory is there. Here, A and B are disjoint, means A intersection B equal to pi. Now that is the empty set is there. Okay. What is the difference of the sets? Here, A complement means here especially A minus B. Because here only elements given in the A, but it is not in the B is there. Here X belongs to A, but X is not in B. That is called A minus B. The difference of any two sets is denoted as A minus B equals to the set whose elements belongs to A and does not belong to B.
Sir, what is the difference between
We write
intersection and
as
difference?
A minus B equal to set of X such that X belongs to A and X is not in B. Here the particularly B minus A is there. X belongs to B, but X is not in A is there. That is the B minus A. What is the universal set? Capital U be the universal set, and AB is also one of the subset is there. What is the complement of A? Means the set of all those elements of U which does not belongs to A. Okay, all the elements does not belongs to A. Here A complement is denoted by here XB is only one of the element, but X is not in A, and that element is also consisting universal set. Okay, that is the universal set example. See this example here. Capital A equal to A, B, C, D, E, F. Now these are all alphabetical small letters. Okay. Now enter all those elements, some elements, binary elements. Okay. Now these are all objects. Objects are represented as in the alphabetical letters, in the small letters. Those elements represented as the given the set is capital A. And another set is defined part, capital B equal to B, D, G, H. Now, these elements are, these problems are also practiced in the lower classes. Okay. Once you have to see here. A union B. What is the A union B? A, B, C, D, E, F, G, H. That is the enter all the elements in A and B, both sets. That is the represented as A union B. Okay. And A intersection B means that is the common elements given in the both sets. What are the common elements? B and D is the common elements. That is the A intersection B. Okay. Next, in the same manner, A minus B, only those elements, just you have to observe here, A, okay. Now these elements, except these elements given in the set, that is the A minus B, okay. Okay, what is the A minus B? A, C, E, F is there, that is the A minus B is there. And what is the B minus A? And the remaining elements of the A in B is there, that is GH. Okay, B, D elements are also involved in capital A is there, and other than the elements in B is called, that is B minus A, that is GH. Okay. Now just you have to observe all the problems you have to practice in the previous classes. Okay. Now this is the A union B part. All the A elements are A, C. Okay, A, B, C, D, E, F. This is the capital A, that is the Venn diagram, and capital B is the only B, D, G, H. Now these are two sets here. Okay. Now what is the common intersection of this part? A intersection B is denoted by B and D. Those elements are common elements in A and B is there. A minus B is A, C, E, F. This is the A minus B part. And B minus A means only elements G and H other than the elements of A. Okay, except other than the elements of A, in the only just you have to write the B set is G and H. That is the B complement or B, G and H is there. Okay, this is the universal set. A complement, suppose A complement, whole complement is capital A. These are also well practiced in the previous session. Okay, now these are all also one of the example. 1, 2, 3, 4, 5, 6, 7, 8. This is the capital A, and capital B is 2, 3, 5, 7, 11, 13. This is one of the set capital B. Write the A union B. 1, 2, 3, 4, 5, 6, 7, 8,
11, 13.
Very good, very good. A intersection B is
2,
Tell me,
3,
madam.
2, 3, 5, 7.
Very good. And A minus B is there. Without the elements of B. B is also except the B elements in A. That is called A minus B.
1, 4.
Very good.
1, 4, 6, 8.
Very good. Very good. B minus A means only 11 and 13.
13.
Okay, that is the B minus A. Okay. Now these are all already, these problems are also well practiced in the previous classes, and some exercise is also some formulas are there. Irrespective of union and intersection is there. Suppose A, B, and C. These are two sets here, three sets here. A union of B union C equal to A union B of union C. Now these problems are also practiced. Some problems are also here according to these formulas. A intersection of B intersection C equal to A intersection B of intersection C is there. And in the same manner, A intersection of B union C equal to A intersection B union A intersection C. and A union of B intersection C equal to A union B intersection A union C. Okay, now this is just you have to rectify it here. This is not intersection union. Okay, A union B intersection A union C. Now this is the printing mistake. And the complement of A union B, that is A complement. Complement of union is intersection, that is B complement. Okay, and in the same manner, A intersection B complement. Complement of A intersection B equal to A complement. Complement of intersection is union and B complement is there. Okay, and A minus of B union C equal to A minus B. Okay, minus of union means that is the intersection, that is the complementation of the part, A minus C. And A minus of B intersection C equal to A minus B union A minus C. Now, these formulas represented as some problems are also practiced for the given set. Suppose A equal to 1, 2, 3, 4, 5, B equal to 6, 7, 8, 9, and C equal to 1, 2, 4, 6, 7. Suppose these three sets are there. These problems are also well practiced corresponding these formulas. Okay. Now, how to prove the elementary theory proof? Okay. These formulas, how to prove the elementary proof? How to write the elementary proof? First of all, A union of B union C equal to A union B of union C. How to write the elementary proof? Suppose in the left hand side of the parties, take the first one. This is the first one. A union of B union C. Suppose here the entire this is the LHS part. In the LHS is also hello. Okay, some element is there. We have taken the some element, that is the X being one of the element given this session. A union of B union C. That is X is consisting of A. Union means R. Intersection represented as AND. Okay. Now that is the X is in A. X belongs to A, or X belongs of B union C. In the same manner, the if and only if X belongs A or X belongs B, union represented as X is being B or X is being C. Now enter this concept X being A union B, because R represented as union of this part. X being of the element A union B, or R, X belongs to C. Again, R represented as the union of the symbol. Here X belongs to A union B of union C is there. Suppose same element in the LHS and RHS is also here. Therefore, RHS is also proved here. Suppose therefore LHS equals to RHS. And especially 3 and 4, just you have to observe this one. Intersection distributes with respect to the union. So this is the distributive law. Here the union distributes with respect to the intersection. Okay, this is also one of the distribution. Therefore, 3 and 4 both are represented as distributive laws. And again, 7th and 8th one, De Morgan laws. This is the 7th and 8th one. A minus of B union C equal to A minus B intersection A minus C. This is one of the De Morgan law. A minus of B intersection C means A minus B union A minus C. Now, here the 7th and 8th formula both are represented as De Morgan laws. Okay. Now, these are also, suppose here, especially third one, how to prove the elementary proof. What is the third one? A intersection of B union C equal to A intersection B union A intersection C. Suppose LHS is also taken. Here X, A intersection of B union C, one of the element is X is there. Okay. Now here X being one of the element A intersection of B union C. Here X belongs to A intersection X belongs of B union C. In the same manner, if and only if X is in A, or it read as X belongs to A, or X is in A, or X is consisting of A. Okay. Now, suppose X is in A and X is in B, union represented as R, X is in C. That is the bracket of this part. Suppose this is also distributes here. X belongs to A and X belongs to B, or R, X belongs to A and X belongs to C. Now X belongs to A and distributes in this bracket of this part. Okay. Now we enter this concept. X belongs A and represented as intersection. R represented as union. So therefore, X belongs of A intersection B or R. X belongs A intersection C. Okay. Now enter this concept. X belongs to, this is the both of the common part is there. X belongs of A intersection B are represented as the union of this part. Suppose LHS of this part X is one of the element, and the RHS is also same element represented as RHS part. Finally, A intersection of B union C proper subset. It is contained or equal to A intersection B union A intersection C, and this is entered this part is capital X, contained are equal to capital Y, and capital Y contained are equal to capital X. Therefore, A contains B, A contained are equal to B, B contained are equal to A. Finally, A equals to B is there. Okay. Now, remaining all the proofs are also practiced here, because in the time manner, some proofs, these are all elementary proofs. These are all elementary proofs. Okay. In the already we have practiced in the lower classes. Okay. Now here A and B you need two sets. What is the symmetric difference of A and B? That is symmetric difference is denoted by A delta B. Okay. Now this is also one of the multiple choice or any fill in the blank is there. Okay. Suppose A and B two sets here. Okay. This is the problem. What is the symmetric difference? A delta B equal to A minus B union of B minus A. Or in the same manner, A delta B equal to A union B minus A intersection B. Okay, that is the symmetric difference definition. The A delta B means the symmetric difference between A and B of the sets A minus B union of B minus A, or A delta B. That is also another formula. A union B minus A intersection B. Suppose just you have to see this problem. A and B be any two sets. A set is 1, 2, 3, 4, 5, 6. That is one of the set. B set is 3, 5, 7, 9, 11. Okay. This is the A delta B. How to write the first of all? So, we have to find out the A minus B. What is the A minus B? These elements 3, 5 only 3, 5 involved given the A. Another remaining of the elements is 1, 2, 4, 6. That is the A minus B. B minus A is 7, 9, 11. This is the B minus A. Now that is the union of this part. That is called A delta B. 1, 2, 3, 4, 6, 7, 9, 11. That is the overall the elements in A minus B and B minus A. That is called A delta B is there. Okay. Now that is also where I have to practice in another one. Okay. In the same example, you have to find out the A union B is there. What is the A union B? 1, 2, 3, 4, 5, 6, 7, 9, 11. That is the A union B. What is the A intersection B? What is the common elements? 3, 5. Okay. That is the A intersection B. Okay. Now, remaining of this part, what is the 9 and 11 is the A. Okay. Particularly is here 3 and 5. That is the A intersection B. Now, A union B and A intersection B of the common difference. Suppose this is the capital X minus this is the capital Y. What is the X minus Y? We are getting the result is A minus B union of B minus A. Now that is also LHS equals to RHS. Both formulas are also compared. Answer is same irrespective of the formula. Now here the A delta B is the formula is that is the symmetric difference between A and B. That is A minus B union of B minus A, or A delta B is another formula is A union B minus A intersection B is there. Okay, that's enough. This is the main concepts of sets, set theory, and another one is relations. Now, how to explain the relation? What is the definition of the relation? Okay, this is the ordered pair of A and B is there. Now, according to the set theory concept, suppose A and B be any two sets without set definition, relation concept, functional concept. Functional relation of a set, according to the functional relation of a set, we must definition of a group. That is the main concept of algebra. So directly we cannot explain the group definition. First of all, what is the set? According to the set of the elements, the number of elements given in the set, that is called the cardinality of a set. Now those elements are a finite, that is called a finite set. Other than it is an infinite set. Suppose just you have to see the relation between the two sets. Here A and B be any two sets. Now, those sets, you have to represent it as the ordered pairs. A small a belongs to capital A and the small b belongs to capital B. What about the relation here? What is the relation defined by A and B? A cross B. This is the A cross B, treated as A cross B. According to the ordered pair elements, small a belongs to capital A, that is the first coordinate element, and the second coordinate element is small b, that is also belongs to capital B. Suppose here ordered pair of some of the ordered pairs. Those ordered pairs must be given in the set that is called A cross B. A cross B equal to set of A and B is also one of the ordered pair. Here A represented as there are so many elements, elements are there. A1, B1, A2, B2, one of the ordered pair. A3, B3 is also another ordered pair. And those ordered pairs must be the form of the one of the set that is called A cross B is there. But that is not the commutative of this part. Those ordered pairs, that is not the equal part, because ordered pair of A and B not equal to ordered pair of B and A. Here this is A cross B and this is B cross A, because that's why A cross B not equal to B cross A. Finally, different sets A and B are different sets. That means A not equal to B is there. Okay, number of who's the number of elements given in the A? That is called N of A. Who's the number of elements of P? That is called number of P. That is N of P. So finally, N of A cross B equal to N of A cross N of P. That is the representation of this part. Suppose capital A, there are 3 elements given in the set 1, 2, 3. Okay, capital B equals to 4 and 5 is also there. Okay, number of A means 3 elements. Number of B means 2 elements. So that is the N of A cross B equal to N of A into N of B. That is 3 into 2. That is the 6 ordered pair elements is here. Okay. Now see this one of the example. A cross B is there. A equal to 1 and 2. B equal to A, B, C. It is very clear. Please listen carefully. Here capital A cross. How to write the A cross B? 1A, 1B, 1C. Okay. 2A, 2B, 2C. That is the A cross B. How many elements given in the set? So here N of B equal to 3 elements, N of A equal to 2 elements. So there are 6 ordered pairs given in the set. Okay, that is 2 into 3. Formula is also verified here. N of A cross B equal to N of A into N of B. 1, 2, 3, 4, 5, 6. Okay. Again, A cross B means 1A, 1B, 1C. And again, 2A, 2B, 2C is there. Okay. And again, B cross A. A1, B1, C1. Again, A2, B2, C2. Okay. Now, both the E is equal, but there are number of elements are same. 6 ordered pairs. But these ordered pairs are not equal, because 1 and A not equal to A and 1, and 1 and B not equal to B and 1. Okay. Now, that's why A cross B not equal to B cross A. That is the which where here that is also particularly represented as R cross or Cartesian product. This is the Cartesian product R cross R correspond to the coordinate plane in analytical geometry. According to the ordered pair corresponds to the point in the plane. Okay. Now, just you have to practice the check your progress. Now, these problems are also practiced here. Suppose A and B be any 2 sets. Write the A cross B. A cross B means 2, 2, 2, 3, 5, 2, 5, 3. That is the A cross B. B cross A means 2, 2, 2, 5, 2, 5, 3, 2, 3, 5. Okay. Now, just you have to observe the A cross B and B cross A. Is it equal or not? Because at any time, both ordered pairs are not equal here. A cross B not equals to B cross A. And in the same manner, A equal to 1, 2, 3. What is the N of A?
3.
What is the N of A, students?
3.
Yes, very good.
3, 3, 3, 3.
That is the A cross A elements is here A repeated as 1, 2, 3 and 1, 2, 3. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Okay. Just you have to write the A cross A and A cross 5. 5 means that is the empty set. This is one of the problem, and this is also another problem, because 5B means the empty set means there are no elements given in the set. So that is the repeated as the given the set is A cross 5 equals to, that is A equals to 1, 2, 3 is there. Okay. That is the practice session. Now these just you have to check your answers in your in your textbook of end of the blocked is the, these answers are also verified here. Okay?
Yes. Yes.
What is the relation? Okay, now this is the main concept of algebra. Okay, please listen carefully. And further session is also two very interesting concept, that is the algebra. And first of all, we must learn the algebraic concepts. First of all, we must learn the set theory, relations, and functions. This is the basic concept. Now, this is the especially according to this concept and easily to understood the main concept of algebra is there. Okay. First of all, what is the relation? Here, R being any one of the relation, that relation denoted as one of the subset is there. Okay. Now, according to the sets, here A and B be any two sets. Now, here R be any one of the subset. That subset represented as the relation from A to B. So, R defined from A cross B, or R defined from A to B is there. Now we read as R defined from A to B, or R be any one of the relation A to B. That is also represented as R is the relation from A to B, because small a belongs to capital A and small b belongs to capital B is there. Okay, that is capital R be any one of the relation from A to B is there. Okay. Particularly, this ordered pair is consisting of capital R is there. So finally, capital R is contained or equal to A cross B. What is the R inverse? Inverse of the relation is denoted by B cross A. That is B to A. Okay. R inverse means because R with the relation, it is contained or equal to A cross B. A cross B ordered pair element is AB. What is R inverse? B and A. Okay. Now B and A, it is also defined from the relation capital R from A to B. So finally, that is this set is also that is the roster form of inverse relation. Set of ordered pair B and A such that here A and B is also consisting of capital R. Finally, capital R contained are equal to A cross A. Finally, here that relation is called binary relation from the given the sets. Okay, capital R is called a binary relation on capital A. That is the notated as, it read as R capital R be the binary relation on capital A. Okay. Now, those binary according to the binary relation, we have to explain some equivalence concept. What about the relations? What is the reflexive? Equivalence means reflexive, symmetric, transitive. When these three properties, when these three conditions must be satisfied, that is called equivalence relation. Students, listen carefully. Now, this is very most important concept of algebra. According to the sets, relations, and functions, number of times I must repeat it here. Okay. Now, here R be the binary relation on capital A. Okay. That binary relation is defined from A cross A is there. Okay. What is the binary relation A cross A? R be the relation A to A. That is here small a belongs to capital A. That is also A similar A. Okay. And R is said to be symmetric. R be the relation from A to B implies R be the relation from B to A. Okay. In the particularly A similar B implies B similar A. That is called symmetric part. Okay. R be the relation from A to B. That is our taking of this part. And we have to construct that relation is also defined from B to A. So this is the A similar B and B similar A. Here similar B the symmetric relation. And capital R is said to be transitive part. What is the transitive relation? R be the relation from A to B and R be the relation from B to C. Here small a belongs to capital A, small b belongs to capital B, and the small c belongs to capital C. Here capital A, capital B, capital C. There are three sets, and according to the set of the elements, we have to construct the ordered pairs AB. Means R be the relation from A to B and R be the relation from B to C, and we must derive the R be the relation from A to C. That is the transitive part. A to B, B to C implies A to C. That is called transitive relation. Now this is A to B and B to A. That is the symmetric. A to A relation is called reflexive. When these three properties are satisfied, when we will given the set according to the set of this concept, relation concept, when it is reflexive, symmetric, transitive, that is called an equivalence relation. That's enough. There are so many examples here. Now that is not necessary here. Okay. Next, see this one. Definition. What is the equivalence clause? Equivalence clause represented as capital R of A. Okay. Here capital A be any one of the non-empty set. That non-empty set and R be the equivalence relation. Already equivalence relation definition is also just you have to mention here. Okay. And according to the equivalence relation defined on capital A, and we have to explain the equivalence clause. What is the equivalence clause? Capital R of A equal to, here small a belongs to capital A. According to the equivalence relation with respect to the non-empty set of the element in that equivalence relation, we have to construct the equivalence clause. And the remaining ordered pair element is B. That element is also consisting capital A. So that's why the relation of the elements A to B is there. That clause is called equivalence clause. Okay, of A relative to capital R is there. Okay, now these are all also well practiced sums here. Okay, that is not examination is not defined here, especially only definitions it all just you have particularly to see the definitions. Okay, now another definition is here. These are what is the function? Okay, what is the function? According to the relation, we have to define the any two sets. This is the FP any one of the relation. That relation is defined from capital A, the set capital A to the set capital B. That is called a function. In sometimes that function is called a mapping A into B. Okay, FP any relation is defined from A into B is called the function or mapping. Here, small a belongs to capital A, and there exists a unique element is small b is also belongs to capital B. Here, the FB the relation from A to B, that is called the functional concept of function or mapping definition. Okay. Otherwise, F is defined from here. F of A equal to B is there. Just you have to see this one. F of A equal to B. So FP any one of the relation from A to B is called that functional relation is F of A equal to B. In sometimes that is also called FB the relation from A to B. According to the relation concept, we have to define the functional part. Here A and B be any two sets. Here small a being one of the element in capital A, and there exists unique element is small b is also belongs to capital B. Okay. What is the AFB? It read as F of A. AFB means F of A equal to B. Okay. Now, this is the concept of F of A equal to B means FB the relation from A to B. Okay, that is the functional definition. In particularly, in the relation, that function is denoted by F maps A to B. F maps A to B. Here, A be the domain and B be the codomain of F is there. A be the domain of F and B be the codomain of F is there. Okay, that is the functional relation. Suppose that functional relation is denoted by here. What is the concept? The set is consisting of the image of the set. Capital A be the one of the set is there. What is the image of the set? B means F of A. That is the image of the set. Image of the set means that is the range of F. Image or range of F equals to set of F of A. Here for all small a belongs to capital A is there. Okay, just you have to see there are so many functions here. F maps A to B. This is the capital A and this is the capital B. How to write the F of A to B? Okay, here capital A equal to A, B, C, D, and this is the four elements. Cardinality of the set mod A equal to cardinality set means P of A equal to 4, N of A equals to 4, and N of B equals to 3. That is the mod B. Then who's the elements in B? That is called the cardinality of B. The number of elements given in the B, that is called order of the set or cardinality of a set. That is 3 is there. What is the functional relation? AP, BP, CR and DR. This is the capital F. G is also defined here. Okay, that functional relation is denoted by cap R equal to AP, BP, AR, CR, DQ. Now it read as, is it a function? This is not a function because those elements here, small a belongs to capital A. There are two distinct elements P and R in B. Only there are two elements A, P and R in B is there. So the relation capital R is A to P. The relation defined from A to A and R. Okay. This is F maps A to B. This is G maps A to B. And this is H maps A to B is there. Okay. Now, these problems are also practiced comparing it with here. Okay, this is different elements. A and B is also there, and B and Q is there. But here C and D is connecting with the R. So this is not a function. Different elements of the each element represented as in the codomain, that is called the functional relation. Okay. Now this is also one of the practice here. What is the surjection injection? Very important concept. Number of theorems repeated according to these definitions of the and defined on the functions. F maps A to B be any one of the function. That function is said to be a function defined on A into B. The range of F contains B. Okay, the range of F contains B. Now not necessarily equal to B is there. Okay. Injection of this part. What is the injection? Injection means one function. Please note down. Injection means one function. Different elements and different images. Okay. Now A, this is the A being one of the element, and codomain of the element is A dash. But both elements are in the same. A and A dash, both elements are in A. So F of A minus F of A dash implies A equal to A dash. But here at the same time, OR A not equal to A dash means F of A not equal to F of A dash. Suppose if A equal to A dash, that relation is also F of A equal to F of A dash, and that is also one mapping. Okay, that mapping is called one mapping or injection mapping. The different elements express the different images, different elements in the domain and the different images in the codomain. That is called the injection of this part. That is the one mapping. Okay. Now, in the same manner, what is the surjection? Surjection means that is the onto map. Suppose small b belongs to capital B is there. The codomain of the element B is also one of the element in the capital B set, and A is also one of the element. Before that, there exists A is also one of the element in the capital A. What about the relation A and B with respect to the function? F of A equal to B is there. And that means range of F represented as capital B. So that is called onto of this part. Okay, onto means that is the surjection. A mapping when it is injection or surjection. A mapping when it is one and onto, that is called bijection of this part. Okay, now that is one of the very important concept. Particularly here A is there. A is one of the set is there. B is also another set. What is the functional relation? 1 C, 2 and B, and 3 and A. So 1 goes to C, 2 goes to B, and 3 goes to A. Okay. In the same manner, according to the A and B, what is the range of the function? What is the range of the function? A, B, C. Because there are 3 elements. Okay. A, B, C. With respect to the functional relation, we have to define the range of the value is second coordinate of the elements represented as codomain or range of the elements or image of the elements. That is also when the ABC represented as in when the range of the function is on capital B is there. Okay. Now there are so many examples here. The functional relation F it is defined from R to R. Here small a belongs to capital R. F of A equal to the codomain is also in the same part. That they are all the square of the elements in the image of this part. So F is defined from R to R. F of A equal to A square. For all here A belongs to R is there. R be any one of the real number is there. Okay. It is neither an injection because suppose A equal to 1 is there. F of 1 equal to 1 square. That is 1. F of minus 1 equal to minus 1 whole square. But minus 1 whole square equals to F of minus 1. Because this value is 1 and this value is minus 1 is there. Okay. Minus 1 square means minus 1. Okay. It is not a surjection. So F of A equal to A square represented here because A being one of the real number, that real number is consisting with the relation F of A equal to A square. That's why F of A equals to minus 1. So it is neither an injection nor a surjection. Okay. So it is not 1 and not onto. Okay. Now here suppose we have to take in the complex numbers given in the both part, domain and the codomain of this part. F of x equal to x square. Now that relation represented as 1 on 2. According to the complex number, x being one of the complex number, that complex number defined on the relation f maps C to C, f of x equal to x square. Now it is a surjection but not an injection. So students, please listen carefully. Now this example here, x being the complex number. Now according to this relation, we must define the concept is given the functional relation is on 2, but it is not 1, 1. Okay. Now f maps Z to Z. Z to Z means Z being the integers, the set of all integers in the domain, and the same set of all integers in the codomain of this part. Suppose here a being one of the integer. Now according to the relation, f of a equal to multiples of 2 multiples. Now that is 2a. F of a equal to 2a. Now this is the 1, 1. It is clear. According to this relation, this is 1, 1, but not a surjection. Suppose just you can see given the final examination, write any suitable example for an injection but not a surjection. Now here f defined the map Z to Z, the functional relation f of a equal to 2a. That's enough. Here in the same manner, what is the bijection of the example? Means now given the mapping of the relation, when it is 1, 1 and on 2. 1, 1 means f of a equal to a plus 1. Here a being the integer. Integer means either negative integer or positive integer. And according to this relation, now it is a bijection. Bijection means first of all we must prove that according to this relation, when it is 1, 1 and on 2, or when it is injection and conjunction. That's why given this relation is a bijection of this part. Now in examination, now this example is also very, very important. And after its completion of this session, we will start the definition of a group. Tomorrow we will begin the definition of a group. That is the minor part. That is the main part of algebra according to this concept. Okay, listen carefully. F maps A to B, G maps B to C. There are two functional relations here. What is the G circle F? G circle F means B to C. Okay. And G is also, first of all, you have to take the functional relation is F is there. What is the functional of this part? A to B. Okay. Here, G circle of with respect to X equals to G of F of X. That is called the product or composition. Okay, students, please listen carefully. Composition means product. Okay. In sometimes that is also multiple of this part. What is the G circle of F of X? Here F is defined from A to B, G is defined from B to C. This is the A and this is the B, and F is the one of the relation. The relation from A to B is there, and again G is also relation from B to C. Another one is C is also one of the set is there. G circle F with respect to X means G of F of X. Here X being one of the element given the set capital A. So that is called, this relation is called product or composition of F and G is there. There are two composition of mappings. Okay. Suppose here one of the example, this example is also must be referred in the final examination. Now this is also a lower classes also you have well practiced here. F and G be any two functional relation defined from R to R. Okay. Here F of X equal to X square. This is the second degree polynomial. This is the first degree polynomial. Okay. This is the first degree of this part. This is the second degree of the polynomial of this part. Now here the functional relation is x square plus 3x plus 1 and g of x equal to 2x minus 3. Okay. But how to find the g circle f of x? G circle f of x means g of f of x. First of all, f of x is x square plus 3x plus 1. We must note down here. G of x square plus 3x plus 1. Okay, replacing x by x square plus 3x plus 1. That is g of f of x. G of f of x means x square plus 3x plus 1. You have to mention here. Okay. Now, just you have to observe here. What is the g of x? G of x means 2x minus 3. What is the x? X means f of x. That is x square plus 3x plus 1. Okay. So 2 of x square plus 3x plus 1 of minus 3. We are getting the result is 2x square plus 6x minus 1. In the same manner, f circle g of x. What is the product of this part? f of g of x. Okay, f of g of x means 2x minus 3. 2x minus 3 is some element, some x is there. Now, according to the functional relation, replacing x by 2x minus 3 means 2x minus 3 whole square plus 3 into 2x minus 3 plus 1. That is the relation of f of g of x. We are getting the result is 4x square. After the simplification, we are getting the result is 4x square minus 6x plus 1. But here, especially in the composition of the part, when the algebraic properties, students listen carefully. This is very main important concept. Okay, f circle g not equal to g circle f. Here, AB not equal to BA. That is the commutative part. Algebraic properties means closure law, associative, existence of identity, existence of inverse, commutative. Okay, these 5 properties. The first 4 properties are closure property, associative, identity, inverse. Okay, especially just you have to see here f and g be any two functions when it is not equal here. F circle g not equal to g circle f. That's why this is the good example of commutative part. Okay, just you have to refer the further concept. That is the group definition, and some more examples are also. You have to explain the commutative group. Okay. Now write the example of commutative group means f circle g not equal to g circle f. That is not commutative. Here AB not equal to BA. The functional relation f circle g not equal to g circle f. Okay. Now this theorem is also very important. Now these theorems here f maps A to B, G maps B to C. There are 2 functions. G circle f means g of f of x. G circle f means A to C. That is the result of the corresponding to the relations. G circle f means B goes to C. Here G of f of x, A to B and B goes to C. We are getting the result is A to C. That is the G circle f. That is the product of mapping or projection of product of part or composition of part. Okay. Now here these 2 functions are when it is bijection, and automatically we are getting the result of this part is also a bijection. Means we must prove that G circle f is an injection and surjection. Now finally we are getting the result is G circle f is also a bijection is there. Okay, what is the f maps A to B? What is the inverse of this part? According to this, this is the bijection part. F maps A to B. What is the f inverse? B to A. Okay, f of A equal to B. F inverse maps B to A is also well defined here. Okay. Now this is also one of the good example of inverse of the function. F maps R to R. Given the functional relation here, x being one of the real number is there. F of x equal to, given the part is 2x plus 3 by 5. What is the f inverse of x? Okay, f is 1, 1 and on 2 because that is the bijection of this part. F inverse is also exists because f of x equal to y and y equals to f of x or f of x equal to y. Given the function is 2x plus 3 by 5. What is the x? 2x plus 3 equals to 5y is there. Okay. And x equals to 5y minus 3 by 2. That is the value of x. According to the relation is f of x equals to y. This value is equal to y. 2x plus 3 by 5 equal to y. And the cross multiplication 5y is there. 2x plus 3 equal to 5y. And 2x equal to 5y minus 3. X equal to 5y minus 3 by 2. That is the inverse of the value. Now f inverse of y means here f inverse of x. F of x equal to y and y equal to f inverse of x. That's why f inverse of x equals to 5y minus 3 by 2. That is the main result is there. Now this is also one of the fill in the blanks or objective type whatever it is. Okay. Now check your answers. Now at the same time, this last but not least here in the modular arithmetic. Okay. Already time is over. Tomorrow we will explain the modular arithmetic, well-ordering principle, and according to the well-ordering principle, before that we have to explain the mathematical induction concept. And when these 2 relations must be especially defined the further algebraic concept. Okay. Now tomorrow we will start group concept is there. Now don't miss it. Now that is also very important concept from the beginning of this part, especially in algebraic concept, groups, rings. Okay. According to the group concept, we have to discuss. We will discuss the definition and some simple properties of group and some other examples and some particular binary operations, special binary operations. We will define tomorrow's session. Okay. Thank you one and all, and wish you all the best. Don't miss it. Tomorrow we will discuss the definition of a group and some more concepts. Okay, thank you one and all. Please note down my number once again: 9989476833. Now, hello. Okay. Hello. Please note down my number. Any doubt? We must contact through WhatsApp is there. Please add my number and create the one of the group. Algebraic group is there. Okay, algebra 2022. Just all the students to form one of the group is there. Okay. Okay. Any doubt?
Okay, sir.
Okay, as an personally we will contact here. Any doubts we must rectify through WhatsApp. Okay. Thank you one and all. Wish you all the best.
Thank you, sir.
Any doubt I will rectify. Don't bother about here. All doubts are rectified through WhatsApp. Okay. Thank you. Tomorrow same time, same class. Okay. Okay. Anyhow, wish you all the best. Thank you one and all.